We're traveling to a new world in a galaxy far away. So imagine the scene. The doors open on a distant planet. An astronaut exits. But he's been in space for too long. Brain damage from radiation, with weakened muscles and bones. He staggers, falls, and breaks a leg. Houston, we have a problem. If long-distance spaceflight does this to our bodies, will we ever reach the stars? Our days on Earth are numbered. In the far future, our life-giving sun will engulf us all. And right now, we're sitting ducks in a celestial shooting gallery. An asteroid might strike at any time. Meanwhile, global warming threatens mayhem. Droughts could strike. Ice caps melt. Rising sea levels might drown us. Perhaps our only option? Get out of town. To boldly search for a new home far out among the stars. To go where no human has ever gone before. Founding a new colony on a planet in a distant solar system. Come join us on this journey, if you dare. Our quest is more perilous than any before. Danger lurks at every turn. And might we ultimately become a new species that's not quite human? Our journey to the stars is a fiction. But real-life scientists in real-life laboratories are working to make it reality.
Once you go off into outer space, you're not going to come back. That group of people will evolve into a different species.
For things like space travel, if humans could hibernate, that's a way that we could remain intact for a longer period of time.
The most efficient way to populate the space crew is to begin with young couples.
But don't start packing your bags. First, we need a destination, and we're a delicate species with a long list of wants. To survive, we need oxygen, water, heat, and food. Basically, we're searching for a planet just like Earth. We've sent probes to Mars and to Saturn, but nothing there can sustain us. We need to look further, much further from home. Since 1995, astronomers have discovered more than 100 planets orbiting distant stars beyond our solar system. They're finding more every year. Could one of them meet all of our needs? Engineer David Miller is helping to design the Terrestrial Planet Finder, a revolutionary telescope that might just pinpoint our perfect home.
Given how many planets we're finding, I would love to be able to identify one that would say clearly, once we have the capability, that's the place to go.
Like Earth, our new home must be near enough to its star to keep us warm. But that close to its sun, we'll never be able to see it. Miller's Planet Finder blocks out that blinding light of the stars and reveals their hidden planets. Once the giant telescope locks onto a planet, it detects oxygen and other gases. It can even tell if the planet has water.
If we could really identify and point up in the sky and say that planet has a pale blue dot around it, that has oceans and atmosphere that we might be able to breathe, I think that would really give us a new perspective on our place in the universe.
So in as little as 10 years, we could find an Earth-like planet But space is big, seriously big. Just how long would our trip take? NASA's fastest vehicle is the Voyager interplanetary probe. Top speed, a staggering 39,000 miles per hour. Los Angeles to New York in under 4 minutes. But still 8 years to get to Pluto. And getting to the nearest star, Alpha Centauri, means 70,000 years in space. To reach Earth 2, we need something faster. Very much faster. Most propulsion in space uses a basic principle, as demonstrated by Dr. George Schmidt.
Concept is best illustrated using a balloon. Fill the spacecraft with propellant, and then ignition. It produces a thrust.
Rocket thrust can get us to escape velocity, the 25,000 miles per hour required to break free from the grip of Earth's gravity.
17 Houston, you are go for orbit. Go for
The trouble with rockets is, the faster we go, the more fuel we need. More fuel means a heavier ship. A heavier ship must have more fuel. It's a classic catch-22. Perhaps we could build the ship away from Earth's gravity, same way they built the International Space Station. Once in space, it takes minimum energy to accelerate. Like a hockey puck on ice, a little tap sends us a long, long way. So forget gas guzzler rockets. Get something light and fuel efficient. Bring on NASA's Deep Space One. 35,000 miles per hour, launched in 1998 and powered by a super-efficient ion engine. Forget chemical fuels. This engine ejects electrically charged gases to propel itself forward. But even ion engines carry fuel. Can we build a ship that needs no propellant at all? Imagine a spring-loaded mast releasing a sail the size of a football field, a solar sail. Sunlight bounces off the aluminum and gives it a tiny push. It will accelerate and accelerate, theoretically to 100,000 miles per hour. And it's not a dream. NASA now tests sail material on a small scale. Solar sails could travel vast distances, but speed remains a problem.
Solar sails are probably the best candidate for exploring regions beyond the solar system, but still we're going to be talking about thousands of years transit time.
Still way too long for our journey. But there is another idea out there, and it's pretty out there. Antimatter. It's the kind of thing you need a physicist to explain, like Michio Kaku.
Anyone who's seen Star Trek wonders, well, why can't we simply build antimatter engines like on the Enterprise? Well, antimatter exists.
But it's only created naturally, in rare ultra-high-speed collisions, such as those that happen inside solar flares. It's a particle of regular matter with its electrical charge reversed. So dramatic things happen when antimatter meets matter. Total annihilation, releasing huge amounts of energy.
If I had a teaspoon of antimatter, I can essentially mimic the power of 100 hydrogen bombs. That's how efficient an antimatter engine would be.
Now, scientists produce antimatter on Earth. But it's a slow and costly process. Creating a gram of antimatter would cost more than $60 trillion. A little outside our mission's budget. NASA can produce trillions of antimatter protons. Sounds impressive, but that's no more than the energy in a book of matches.
To get to where we need with propulsion, we'd need something that could store maybe 1,000 times that.
And so far, all of Schmidt's bag of tricks are designed for unmanned probes. No use for our exodus to another planet. Ironically, in 1957, scientists may have been better equipped to propel us into space than now. Project Orion planned a spaceship the size of an ocean liner, accommodating 150 people. Their motto? Mars by 1965, Saturn by 1970. This was the atomic age, so nuclear explosions would propel the ship, each detonation bouncing the spacecraft forward.
Project Orion, you're like a surfer. You would literally surf on the basis of the shock wave created by miniature hydrogen explosions.
The scientists staged a test in California in 1959. Being safety conscious, they abandoned nuclear blasts for conventional explosives. Each explosion successfully powered the unmanned capsule upwards. But then came the doubts, worries that powerful nuclear explosions would kill any crew or damage them with the radiation from nuclear blasts.
The scientists realized that it was a Pandora's box. Yes, they would open up the secret of the stars, but hey, are we mature enough to tamper with this kind of nuclear fire?
Back to the drawing board. Today, NASA is cautiously revisiting nuclear power, but on a much smaller scale. So nothing can get to Earth 2 in one lifetime. Generation after generation will need to live on board, on a ship in the most hostile environment imaginable. Deep space. No air, no gravity. Trillions of miles of nothingness. How will we ever survive on this journey? Our imaginary deep space quest is fleeing Earth for a new home among the stars. We've found the right planet. Now we just have to get there. Fastening our seatbelts for takeoff, we ask, can we survive this journey? Our first challenge comes almost at once. Losing a force that has shaped us all our lives, gravity. Back home, every movement is a struggle against gravity. Needing strong bones just to stay upright, and powerful muscles to move us around. It even teaches us what's up and what's down.
Jane Houston, you are go for orbit. Go for orbit.
Heading for orbit, we hit zero gravity. Floating gracefully, life in space seems easy. But without gravity, we are like fish out of water. Our newfound strength is an illusion. Our muscles are wasting away.
We have the thrill of being a Superman. All of a sudden we can lift gigantic instruments. All of a sudden we can perform dazzling feats, even as we're becoming weaklings.
In 1983, to study the effects of reduced gravity, Dr. Norm Thagard embarked on the US Space Shuttle. He noticed his body altering. His muscles were shrinking away.
I lost about 20% of the muscle mass from the calf muscles and about 10% from the thighs. And your heart's a muscle, so it will get weaker as well.
The absence of gravity weakens our muscles and leaches the strength from our bones, because bones stop growing in zero gravity. Back on Earth, every time we run or walk, the impact triggers fresh bone tissue growth. In space, that trigger is missing. You can measure this effect by staying in bed. Total bed rest is as close to zero gravity as you can easily get. In 2005, NASA immobilized volunteers for 3 months to weaken their muscles and bones. Raising their feet makes blood rush to their heads, as it does in space.
A little uncomfortable. It takes a little getting used to. It's hard to sleep at night sometimes.
Physically, it's difficult to move around, to brush your hair at this angle, to eat at this angle.
It's about as close as I can get to be an astronaut without actually doing it.
Within days, their bones are less dense. But it's not all bad. For a special treat, they get to go outside. Pretending to be in space for just a few weeks affects our test subjects. How would they cope for a year? Some Russian astronauts have spent that long in space. Returning to Earth, they no longer have the strength to stand in gravity.
They're almost like a bug crawling on the surface of the Earth, trying to regain their strength.
And if it's that bad that quickly, how would we cope? We will be in space for generations. If current predictions are anything to go by, a year into our journey, a young male astronaut's leg looks normal. But underneath, he might have lost 15% of his bone density. 2 years later, as we approach Jupiter, a fall could easily result in a fracture. And by Saturn, a pat on the back could crush his spine. And there's hundreds of years still to go. We need a way of bringing gravity with us. At MIT, Dr. Larry Young thinks he's found a way to do just that.
Why don't we try to replace gravity? Why don't we try to figure out some way of preventing the problem in the first place rather than repairing the damage?
His answer: use a centrifuge. A centrifuge creates its own force. It's not gravity, but resisting that force still stimulates our bones to grow. But our centrifuge has to be portable. So Young's team builds one small enough to fit on our spaceship.
You would not live on it, but you would spin on it, what I call a spin in the gym.
So here I am, being centrifuged at a modest G level. It's perfectly comfortable. Feel a gentle breeze over your feet.
It makes you dizzy at first, but just an hour a day will keep our bones strong in space.
It's kind of an unusual feeling because the sensation you get lying here during this rotation is that the entire world is turning around you.
But it's a heavy contraption. We need something lighter. Prepare to enter the spin cycle. One of Young's students has designed this bicycle within a centrifuge. Cycling in circles, it's self-propelled, so no need for a heavy engine. And it gives our muscles a workout at the same time. Maybe we could overcome the immediate effects of zero gravity. But our journey will take centuries. Entire generations will have to adapt to work, rest, and play in an environment totally alien to Earthlings. And here's a thought. What will happen to the first human embryos developing without gravity? Our only clues come from work on the Russian space station Mir. It was a mini Noah's Ark, a mobile lab exposing plants and animals to zero gravity and recording it on tape. Astronaut Norm Thagard was on Mir, researching how zero gravity affects reproduction. Too dangerous to take a pregnant woman into space, so he studied eggs. Quail's eggs.
The idea was to see if birds could develop normally, embryologically, in the conditions of weightlessness.
But none of them hatched. It was a worrying finding. Do unborn creatures need gravity for proper development? It's a massive problem for our long-distance trek.
Certainly you wouldn't want to have a pregnant female crew member on a flight in weightlessness until we've had a chance to examine some more of this.
How can we cut our umbilical cord to Earth if we have to return home to give birth? It's every parent's nightmare. Our babies may not develop as they should. At the University of Indiana, Jeffrey Alberts thinks gravity is crucial in embryo development. It helps us develop a sense of balance. If Alberts has his way, by 2007, the International Space Station will be crawling with rats.
Although we're not just big rats, there are so many similarities that they are an invaluable source of information.
We have a similar inner ear, or vestibular system, to that of our furry friends. Like a carpenter's level, our inner ear uses gravity to help our brain figure out what's up and what's down. Alberts demonstrates its importance by taking a baby rat for a swim.
Here's a 2-day-old rat pup. We can have a conversation with it and ask it the simple question, can you tell up from down? Can you tell the direction of gravity in your world? By turning it into its unpreferred position.
This test in no way harms the animal.
And place it just below the surface in this warm bath and give it time to tell us if he knows his directions.
A normal rat pup like this one senses gravity from below and rights itself.
But you saw that lovely orientation. Now it's going to wipe its face. And it's been protected from breathing in any of the water by its dive reflex.
These Earth-born rats experienced gravity all the time they were in the womb. What happens when we develop without gravity to point us in the right direction? Albert sends a group of pregnant rats up in the shuttle for 11 days. It's the longest any pregnant mammal has been in space.
All theory that we had told us that what we should find is a vestibular system which is not normal.
The rats return to Earth to give birth, and Alberts is right. When he checks their babies for gravity awareness, they don't know up from down.
Here's one of our stars, dropped in the water, and there he goes right onto his head. Here's one animal who just does not detect gravity the same way a normal animal does, and they come back to Earth and they're telling us they don't feel the world the way a normal animal feels it, the way that we do.
It takes 3 days for Albert's rats to recover their sense of orientation, which is a clear and disturbing warning for our mission.
The longer crew members spend in space, the more aware we should be about how they'll continue to function in that world with no gravitational cues.
So leaving Earth could weaken us and make reproduction difficult. But bringing gravity with us could help. But that is only part of the problem. Continuing our journey, eventually we'll have to go outside to make a repair. And that exposes our crew to a new peril, the vacuum of space. In 1993, NASA's repair of the Hubble telescope tested the limits of man's exposure to space. 4 astronauts spent a record 35 hours floating outside the shuttle, attached only by a tether. Their spacesuits were the only thing protecting them from the freezing cold vacuum of space. Jeff Hoffman was one of the astronauts. Now a professor at MIT, he has logged more than 1,200 hours in space over 5 missions.
We looked at it almost as if we were doing choreography. We knew what the tasks were that we had to do, and therefore we could plan almost every move.
The repair is intricate, the conditions extreme, and all the while, Hoffman has to wrestle with his bulky spacesuit.
You can't think that you're just working with your own body, because you'll end up fighting against the suit, and frankly, the suit's stronger than you are, and you'll lose.
The suit saves us from the extreme temperatures, while pressurized gas within the suit protects against the lack of any atmosphere. Without the pressure, we would suffocate in the vacuum of space. But the current design is frustrating. On Earth, it would feel like wearing a 280-pound NFL linebacker. But it's not just the mass of the gas-filled suit. The gas pressure stiffens the body, making bending arms and legs hard labor.
Imagine trying to do brain surgery when you're wearing ski gloves, and you get some idea of what I'm talking about.
How can we keep our ship in working order with these limitations? Hoffman is working with MIT engineer Dava Newman to revolutionize the current spacesuit. She applies pressure in a radical new way. Her biosuit replaces the gas with elasticized material. The result? A tight-fitting, lightweight suit that still exerts pressure. Think slim diving suit, not bulky spacesuit.
So it's literally like putting on a second skin and applying the pressure that's necessary to keep someone alive.
To replace pressure provided by gas, she uses material that can exert the same force directly onto the skin.
I have this elastic material that I can now wrap around my skin, and that produces pressure just in the way that the gas inside a spacesuit produces pressure.
Our suit must be as close-fitting as possible to give us increased mobility. So Newman maps out the human form with computer imaging.
You want maximum mobility. You want the folks to be able to walk and lope and explore and get down on their knees.
The prototype leg may lack in looks, but does offer increased flexibility compared to the gas-filled suits of today. Newman tests it by rappelling down this mini mountain, the closest to Mars Massachusetts has to offer.
I have really good knee mobility as well as my entire leg. You could never do this in a conventional spacesuit.
The biosuit system could include sensors, temperature gauges, and computers, all designed to create our perfect spacesuit. It could even be covered in fibers that act as artificial muscles to enhance our strength.
You know, we actually have the possibility of doing some of this stuff in the next few years rather than just dream about it.
We're getting closer. We know where we're going. We can substitute for gravity on board. We even know what to wear. But something invisible is lying in wait. It's deadly and can tear through our bodies like machine gun fire. Let's be careful out there. Naked Science is on an imaginary interstellar journey, a trip taking hundreds of years. We've set our sights on a new home in a distant solar system. Overcoming all the obstacles will test our ingenuity to the limit. But brace yourselves. We are about to encounter the most deadly enemy of them all: radiation. Back home, we enjoy the sun's light and warmth. But every so often, the sun seems to get angry. Solar flares fling billions of tons of deadly radiation into space. The Earth's magnetic field protects us from this lethal shower. But caught outside our ship, when a flare strikes, an astronaut will be dead in 10 hours. Relax, though. Flares don't happen that often, and NASA officials are confident they can warn us of this impending danger. But there's something far more insidious out there: deep space radiation. Invisible rays spewing out from distant stars, hurtling through space, peppering anything in their path like machine gun fire. Now, imagine closing your eyes and seeing these cosmic rays passing through your body. That's exactly what happened to the Apollo 11 astronauts in 1969. Gazing out of their space capsule, they witness amazing sights. The breathtaking view of Earth receding into space, the far side of the moon, and strange flashes of light inside their eyeballs. Back on Earth, the crew report these light flashes to Mission Control. NASA immediately contacts physicist Lawrence Pinsky to investigate.
I've also had some very subtle, looks like little dim flashes that I haven't been calling. They're just so subtle.
In some cases, they reported them as looking like lightning in the clouds. In other cases, they looked like stars or spots. In some cases, streaks.
Once the story breaks, other astronauts follow suit and admit to seeing them too.
The astronauts were reluctant to report anything that they felt that might remove them from flight status, and being up there and seeing flashes of light, nobody else was reporting them, so you didn't want to be the first one to say, hey, I see spots before my eyes.
Pinsky suspects the flashes could be harmful, but it's not until the Apollo 16 mission 3 years later that he's able to rig up a test. He has the astronauts cover their eyes and report the light flashes. Pinsky discovers that it's not light hitting their eyes, it's cosmic radiation. Each ray striking the astronaut's retina fools the brain into thinking it's light. The radiation seems to have no immediate effect. But NASA later find a staggering 1 in 6 former astronauts they studied suffers from cataracts, higher than the Earthbound average. They face a clouding of the eye and eventual blindness. So the cosmic radiation is doing damage. And as we go farther and farther into space, we are at risk not just for cataracts, but possibly for cancer. So if the radiation is passing through our eyes, what is it doing to our brains? Back on Earth, at the National Laboratory in Brookhaven, New York, Marcelo Vasquez is trying to find out. He reproduces cosmic radiation to gauge its impact on our brain cells.
We are concerned that cosmic rays will produce brain damage.
Vasquez is working against the clock. He's got till 2010 to solve the problem, or NASA will ground all manned long-distance space flights.
We don't want to have astronauts that reach their target and they are not able to land or operate or to function and remember or perform.
Vasquez is using live stem cells, but they're fragile, so every second counts.
The cell cannot be more than 10 minutes outside the incubator, basically.
Identification is completed.
Brookhaven's heavy ion beam is the only one dedicated to this research in the United States. Cosmic radiation travels at over 160,000 miles per second. That's almost the speed of light. Vasquez shoots the beam through the cells.
It's coming up, 59, 79, 99. Dose delivered. Well, look at this. This cosmic ray is like a bullet going through the nucleus of the cells, producing DNA damage. So we can see actually the effect of cosmic ray when they damage the DNA. This is fantastic. And the first indication is that cosmic ray can kill brain cells and culture. And it's very worrisome actually.
If a single blast kills brain cells, we'll need some serious protection on our ship. The shielding material has to be light. So Vasquez tests a sample of polyethylene plastic to see if it blocks the cosmic rays. The shielding proves partially successful, but many of the radiation bullets are still getting through and wreaking havoc on the cells. Is there any way of repairing that damage? Vasquez is already way ahead of us. He's testing specially designed enzymes that could travel through our body and mop up radiation. astronauts could take daily enzyme pills on long-duration missions. Vasquez hopes that within 5 years, he will have found a way to reduce the risk of radiation to manageable levels. So we're another step closer to making our interstellar voyage a reality. But long-distance space travel will play havoc with our minds as well as our bodies. And how would we cope if a crew member goes berserk in outer space, 1,000,000 miles away from help? Naked science has explored ingenious ways of overcoming the physical ordeals of space on a journey to the stars. But as the months turn to years away from the safety of our planet, we face a new test. How will our mental stability last when faced with long-term confinement? On Earth, we think of ourselves as sociable animals, traveling in packs, communicating constantly, and surrounding ourselves with other people. Now, imagine the horrors of living in space 24/7, year in, year out, confined to a trailer home, surrounded by people you can never escape. In 1995, Norm Thagard boards the Russian space station Mir. It becomes his home for the next 4 months, and he learns firsthand the trials of long-term confinement.
You get bored. People tend to get irritable. You get an almost combative state at times. That's obviously not desirable. And when you start talking about crews that are going to be together for a long, long period of time, it's worrisome.
So spiraling tension is a problem even within sight of Earth. But our mission is much farther away than that. So far away that even radio messages take many hours to reach us. If arguments on board escalate into full-blown conflict, Mission Control will be powerless to intervene. We need a calming voice close to hand. But who can offer that? David Dinges, a clinical psychologist at the University of Pennsylvania, believes the answer is a computer therapist.
There will be conflict, and we have to have a system in place where they can resolve those conflicts, prevent them if possible, but certainly resolve them before they get out of hand.
If Dinges has his way, it won't be a fellow astronaut that calls a timeout, but a machine.
Yes. I'd like you to begin with the picture recall task. Let me know when you're ready.
So how will this computer therapist spot the warning signs of growing stress and frustration? Luckily, we humans communicate most of our feelings through facial expressions. Instantly, we can see if someone is happy, sad, or just plain stressed out. Dinges has created a computer program that does the same thing. He tests his stress recognition system on a student. The computer takes a baseline reading by mapping her face at rest. Then Dinges cranks up the pressure so the computer can get a reading of her distress.
Say the colors that the words are printed in out loud. Work as fast and accurately as you can. Let me know when you're ready.
Yes.
Begin.
Red, green, green, blue, 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 red, blue.
Faster.
Green, blue.
Go faster.
Green, red.
You're going to have to keep up and try harder.
Red, blue.
The tasks become more
Green.
difficult.
Red.
Please don't make those mistakes.
Green, blue.
The computer records
Keep your head
each
up.
change
Green,
in facial
green,
expression and
blue,
adds it to the map of her stress response.
Green.
That wasn't very good. Remember to sit still and wait for that score.
In space, a computer would memorize our individual stress map. The computer cannot make things better, but can alert us to the dangers and to deterioration in our performance.
It's not a spy system. It's something they're fully aware is on and operating. The more we can inform them of what's happening to their behavior, the better chance we have of heading off any more serious problem.
But there's another solution to resolve conflict on our voyage. Instead of an elite team of hardened astronauts, our crew should be made up of young couples. As crazy as it sounds, they have the right stuff for spaceship travel. Ellis Island, New York. Tens of thousands of men and women from all over the world endured a long, arduous voyage to arrive here and begin a new life. Among such pioneer travelers, could we find our perfect spaceship crew? University of Florida anthropologist John Moore believes we can.
I love this particular site because it reminds me that someday, inevitably, there will be an Ellis Island in a different galaxy to receive the new colonists from our solar system.
According to Moore, we should be taking family units into space. The hierarchy of a family creates a natural order that will see us through hardship. And being with people we know and love makes it easier to resolve conflicts.
Whenever necessary, human families have the means to survive any rigors that are presented to them.
Moore proposes to NASA that he devise a profile of a future space colony. First, he studies pioneer groups that have survived in isolation. Then he calculates how many couples we would need to survive 200 years with no inbreeding.
I was surprised to learn when I figured the fertility and intermarriage rates that you could go with as few as 100 persons.
So we need just 50 young childless couples to start on our journey. They could procreate on board to form a new population.
The story of the world is diverse people coming together, forming a new tribe that nobody ever heard of, and becoming successful.
And that's what we intend to do. So assuming we have learned how to reproduce safely in zero gravity, Moore's solution could work. But he's only planned for 200 years. We'd still be far short of our destination. What happens then?
I think it's inevitable, on a scale of centuries now, that we're going to have to tinker with the human body itself.
So to get to our planet, are we talking genetic engineering? Prepare yourself for a complete overhaul of the human body. Naked Science is on an extraordinary mission to reach a new home in a distant solar system. So far away, we'll have to spend centuries in space. And only our children's children will reach our destination. Unless we live forever. It's humanity's oldest dream, immortality, and it might just be within our grasp. At the University of California, Cynthia Kenyon thinks she's found a way to stop the clock. She tests her theory on a tiny worm that shares a third of our DNA.
Like us, when it's young, it's frisky. When it's old, it's in the nursing home, and it looks like any old animal of any type.
In 1993, Kenyon discovers a gene that she believes controls aging. She nicknames it the Grim Reaper.
They determine how long it can live and whether it ages quickly or slowly.
Then she finds a way to switch off this gene. To her astonishment, the worms live 6 times longer than normal.
Just look at these animals. They should be dead or in a nursing home, and they're on the tennis court, you know? And you look at them and your hair stands up. You think, my God, they should be dead, but they're not.
In human terms, that means we could live to be 500. And like the worms, remain active all of that time. But hundreds of years on a spaceship feels like a terrible waste of young lives. So Kenyon's made a new discovery that could make the trip more bearable.
Now, it turns out that the same hormones control the aging of the adult animal, also control the ability of the animal to enter this state of suspended animation.
In other words, Kenyon's worms hibernate. Like bears, hedgehogs, and toads, they enter a dormant state where the whole body slows down and aging is arrested. If we could find a way to hibernate, that might just make our trek to the stars a reality. Because a sleeping crew would need less resources. But this is still science fiction. Or is it? In 2005, we get one step closer to our new world. Scientists chemically induce short-term hibernation in mice. But Kenyon believes the answer may lie in hibernation genes, and humans may have one. We just have to find it and switch it on.
And that's something that would be really fun to explore for things like space travel. If humans could hibernate, then that's another way that we could remain intact for a longer period of time.
So we could travel in suspended animation, arriving unaged at our destination planet. But what happens if Earth 2 is not quite what we expected? We can't modify the whole planet, so we would have to find a way to re-engineer ourselves and our children. At Princeton University, Dr. Lee Silver is the creator of a radical school of genetics that seeks to alter the DNA of embryos.
It's just the question of looking at the environment and then imagining what things we could do to change children so that they would live in that particular environment more efficiently.
So all of the problems of our journey could be overcome before our children were even born, if we could just alter their genes.
Genetic manipulation is not science fiction. It's something that is going on right now across the world in animals.
In June 1997, scientists isolated the gene in a jellyfish that makes it glow in the dark. Then, they injected the glow gene into mice embryos. The result? Fluorescent mice. Now, we probably won't need to glow in the dark. But Silver believes because we share DNA with many other species, we can extract the most useful gene from each creature and use them to enhance our own children.
What we learn in any other species that helps that species and that we like, we can bring into ourselves.
So which features from which creatures would we want? One of the most useful genes would protect against radiation, but you might not want to take it. It comes from the humble cockroach, which has just the genes we need to protect us from radiation.
We can use the scientific knowledge of how the cockroach genes work to alter our genes so that the proteins they make that protect against radiation are much more effective.
For now, we're only talking about changing our chemistry and not about morphing into a giant cockroach. But future humans could be made to have stronger bones to withstand zero gravity or more efficient lungs to survive on less oxygen.
The nice thing about being able to change the genes in a child is that they're changed for good.
So in order to safeguard the human race and survive in our alien world, will we have to alter ourselves beyond recognition?
Each group of people that goes to a different planet in a different solar system will become a different species.
Imagine, within a decade, we might find a habitable planet. Within 20 years, we could withstand the perils of space travel. In 50 years, perhaps, we could genetically alter ourselves to adapt to our new home. But let's hope when our children's children finally reach Earth 2, they still look a little like us. And humankind as we know it has been preserved.